Do you want me to upload the solution to all the other questions in this paper on this channel? Then please kindly subscribe to this channel now. Thank you. A particle P of mass 1.2 kg is acted upon by forces F1, F2, F3, and F4. If the acceleration of the particle is a equal 40 meters per second squared, 240 degrees, find correct to the nearest whole number F4. This is WASSCE 2024, paper 2, elective mathematics, further mathematics, paper 2, question number 15. Let's see how we'll go about this. So we will need to calculate the net force. So the net force, according to Newton's law of motion, is F equal mass times acceleration due to gravity. Then again, this will be equal to F1 plus F2 plus F3 plus F4. So we need to resolve the forces. So we have M here is 1.2. It is given in the question. So we have 1.2 times the resolution of the forces, that is acceleration, is 14 sine 240. Then we have 14 cos 240. So this will be equal to F1. The resolution of F1 is also 15 sine 90, 15 cos 90. We add it to F2, 20 sine 0, 20 cos 0. We add it to F3, F3 is, let me add it below here because the space is not that much. So F3 is 30 sine 210, 30 cos 210. Then we add it to F4. We don't know it. We are looking for F4. So we need to simplify this. 14 sine 240 will give us negative 7 root 3. So we have 1.2 times negative 7 root 3. Then we have negative 7 here. And this is supposed to be equal to 15 sine 90 is 15. Then 15 cos 90 is 0. 20 sine 0 is 0. Then 20 cos 0 is 20. 30 sine 210 is negative 15. Then 30 cos 210 is negative 15 root 3. Plus F4. So let's multiply 1.2 by the force to obtain we obtain negative 42 root 3 over 5. Then we have negative 8.4. If we do the multiplication here, the scalar 1.2 times the vector will give us this result here. Then when we add whatever is here, we get 15 plus 0 minus 15, and that will give us 0. So we obtain 0 here. Then when we add whatever is here, we get 20 minus 15 root 3. 20 minus 15 root 3. So we have 20 minus 15 root 3 here. Plus F4. So in decimals, we have F4 to be equal to negative 14.5492 and negative 2.4192. So that is F4 for you, but we need to write it in this form as it was given to us. So this is going to require that we find the magnitude of F4. So the magnitude of F4 will be equal to square root of negative 14.5492 all squared plus negative 2.4192 all squared. When we simplify this, we should be obtaining 14.75 newtons to the nearest whole number. That will give us 15 newtons. Then we need to also calculate the direction of the force. The bearing of F4 can be calculated. You can see the diagram like this. You can see that we have, so let me do the diagram well. We have negative 14.5492 here. Then we have negative 2.4192. It tells us that the force is in this quadrant here. So the bearing will be 180 plus the angle here. So we find this, which is 14.5492 over this, which is 2.4192. So recall that as we are doing the calculation, we are going to make use of, so this is 180 plus this angle here, which is A. So let's find the value of A using this triangle and add it to 180. So we have tan A from the right angle triangle. Tan A will be equal to opposite, which is 14.5492 over 2.4192. We are using only their magnitude, only here, the distance of, or the side length of the triangle. We are using it to find the value of A. So A will be equal to tan inverse of 6.0139 6.01395, and that will give us 80.5592 degrees or 81 degrees. So we add that to 180 to get our alpha to be equal to this alpha here to be 180 plus 81, which is 261 degrees. So the force is actually in the third quadrant, hence F4 is equal to K newtons, which is 15 newtons, and 261 degrees.